Traditional terrain analysis systems are complex and difficult to use, often using cumbersome user interfaces. This can lead to confused and frustrated users. Recently, multi-touch tabletops have been used for map-based tasks because of their natural ability to show large portions of the map and provide panning and zooming functionality. We introduced Terraguide, a multi-surface environment based around an interactive tabletop. Terraguide was designed to address the problems of terrain analysis by providing real-time, tightly coupled techniques that allow for easy switching between them. There are 3 techniques for terrain analysis presented with Terraguide: a real-time viewshed, a 3D panoramic view, and a helicopter view using a tablet. The viewshed shows areas of terrain that are visible from an observation point. Red colors indicate high elevation and blue is low. The viewshed switches to a low resolution mode to allow for real-time exploration. When the user stops touching the viewshed, high resolution pops in. Coupled to the viewshed is the panoramic view located on a screen in front of the table. The panoramic view shows the exact representation of the viewshed, but from a first-person perspective. It is controlled by moving and rotating the viewshed. The helicopter or tablet view shows the terrain from any perspective around and above the table. It displays the view based on its 3D position and orientation in space, captured by 4 optical trackers located on the ceiling above the table. This allows for highly precise real-time fly-throughs of 3D terrain. We performed a user study with 2 parts to evaluate Terraguide. Part 1 was a simple task comparing each technique. Participants used each technique individually to find the highest and the lowest points on the terrain. Completion time, error, confidence, and cognitive load was measured for each technique. Part 2 involved a more complex task where participants used all 3 techniques in combination. Their task was to place 3 watchtowers, represented by viewsheds, to cover 6 points of interest across the terrain. The points of interest were represented by red dots that would turn green once they had line of sight with a watchtower. They completed the task 6 times on different maps. We noticed several different strategies while performing the task. Most participants bimanually used the tablet in one hand and moved their watchtowers with another. There was no barrier between the devices, and participants willingly and enthusiastically used this approach. There were 2 variations on this strategy. 8 participants used the table-first strategy, where they used only the table and the viewsheds at the beginning of the task. Eventually, these users needed to switch to different techniques to help them complete the task. 6 participants used the tablet-first strategy. Participants would get an overview of the terrain with the tablet before attempting to solve the problem. They would then move their watchtowers to possible locations that would give them the best results. We developed a multi-surface environment based around design principles to allow for rapid, real-time exploration with tightly coupled devices that were easy to switch between. This led to the successful and effective use of multi-surface techniques that increase user performance in terrain analysis tasks.